You can view the list of basic Arduino functions by following this link. It includes the functions that you will use most frequently while working with Arduino. First, I will explain from the left in order. I will prepare separate lectures for each command section where I will provide detailed explanations. In the case of digital read, it is a command that reads the value of a GPIO digital pin. In the case of digital write, it is a command that sets the high state of a GPIO digital pin. In the case of digital pins, you need to set the direction before using them for input or output. You have to specify whether it is input or output, and this direction is set using the pin mode function. Next, in the case of analog, reading the value of the analog pin is done using the analog read function. Next, in the case of the analog reference, when using the analog read function, there is a reference value that serves as the basis for reading. Originally, the default values are set to 5V for 5V and 3.3V for 3.3V, but if you want to change the reference value for reading these analog values, you can do so by using the analog reference. Conversely, analog output and PWM control are done using the analog write function. Next, there are functions available for boards like 0 and DUE, such as analog read resolution and analog write resolution. For reference, the analog read function reads values at a 10-bit resolution. However, you can change the reading resolution value with this analog read resolution. You can change the resolution, converting to 12 bits, and similarly, PWM is generally set based on an 8-bit standard. However, you can change the resolution by setting the analog write resolution to 10 bits. This function can only be used on models that support certain resolutions, such as the ones listed here, for the 0 and DUE. Next, the no tone function is used to stop the pulse being sent to a piezo speaker, while the tone function is used to generate a specific hertz pulse. Additionally, the no tone function ensures that the piezo speaker remains silent, while the tone function precisely controls the frequency of the pulse. Pulse in is commonly used with ultrasonic sensors, and you can think of it as setting up an interrupt internally. It measures the distance of the ultrasonic sensor based on how long it takes to wait for the pulse to come in. In the case of pulse in long, there is a default timeout period that is usually set. In the case of very long pulses, it can be cumbersome to use pulse in, so there is the pulse in long function that allows for sensing and confirming. In the case of shift in or shift out, when using interfaces like SPI or I2C, there are clock pins and data pins. When receiving data through an interface with clock and data pins, data is received using the shift in command, and conversely, when sending data, it is sent out using the shift out command. These commands are the shift in and shift out functions. You can use something like this, but generally, Arduino provides libraries related to SPI or the wire library for I2C, so you can use those. Alternatively, if you want to control things more at the hardware level, you can use this method. Next, one of the commonly used functions is the delay function. The delay function pauses the Arduino for a specified time in milliseconds. You can think of it as a sleep function. Then there's the delay microseconds function, which operates in microseconds instead of milliseconds. The function called micros returns the number of microseconds that have passed since the Arduino was booted, based on the continuous clock running since then. Similarly, the function for milliseconds only differs in the unit. It tells you how many milliseconds have passed since the boot. Here are the functions that make mathematical operations easier, such as abs, constrain, map, and allow for mapping, followed by the mapper, map, alma, respectively. They include abs, constrain, map, and allow for mapping, followed by the mapper, map, alma. Mathematical functions such as max, min, power, and sqrt are included, like. Next, similarly, we have the cosine function, sine function, and tangent function. Next, there are also text-related functions that determine whether a certain k-type data corresponds to alphabetical characters like A, B, C, D, or if it is alphanumeric, containing a mix of letters and numbers. It also checks if it is an ASCII code. For example, IceCtrl identifies the values of command keys like Ctrl and Alt, while IceDigit checks if the value is a number. There are also icegraph and iceprintable functions that determine if something is displayed on the screen. In this context, spaces, tabs, and similar characters are ignored because they are not visible to the naked eye. The output must be symbols that can be seen and confirmed by a person. The function printable is similar, but the difference is that invisible characters like spaces, tabs, and carriage returns are still outputted. So, what are the symbols that are outputted? And in the case of hexadecimal digits, can they be represented as characters like A, B, and numbers from 0 to 10 in hexadecimal form? Also, is lowercase referring to lowercase letters, and are punctuations abbreviations for symbols like periods or commas? In the case of is space, does it refer to tabs or spaces? And similarly, for white space, I need to check this. When looking at is uppercase, it indicates that it is uppercase. In the case of is space, it recognizes everything including carriage returns and such as correct. But for white space, it is designed to distinguish and only check for tabs and spaces. In the case of random and random seed, the random function generates random values. Before using this function to output random values, the random seed command initializes a seed value by inputting time values or analog. Noise values too generate the random numbers. After that, the random function can be used to continuously receive random values as desired. Next, there are convenient commands related to bit manipulation. With these bit commands, you can input values like 1, 1, 0, 1, 1, 0, 0, 1, 0, 0, 0. But if that seems tedious, you can use the bit commands instead. So, using bit 0 means just 1, and using bit 1 means 1, 0. The bit functions are designed to make it easy to input values like 1, 1, 0, 1, 0, 0. Bit clear is used to clear a specific bit at a certain position, while bit read is for reading a bit at a specific position. Bit set is similar to bit write, but bit set specifically sets a bit to 1 at a certain position. In the case of bit write, it can set a bit to either 1 or 0 at a specific position. High byte and low byte refer to values that are more than 1 byte, such as 2 bytes or 4 bytes, where high byte retrieves the most. Significant byte and low byte retrieves the least. Significant byte from values like 16-bit or 32-bit. Next, there are commands related to interrupts, and setting a specific interrupt for a hardware pin is done using the attach interrupt, and detaching the interrupt is done using detach interrupt. Next, enabling the interrupt is done by activating the interrupt settings, while disabling the interrupt is done by deactivating the related interrupt functions. There are these commands. In addition, there are libraries related to SPI, stream libraries, as well as keyboard libraries and mouse libraries. And if you scroll down a bit more, you'll find variables that will be frequently used on the Arduino side. Constant variables, however, for those who are familiar with C++ data or similar topics, this is almost just a repetition of the same information. In addition to those, here you can see things like high and low levels, and when setting up digital pins, you have input, output, and input pull-up. For the built-in LED, it is represented as a macro constant. In Arduino, there is a basic LED, and the pin number for that basic LED is indicated by a macro constant. If you have done true pulse, you all probably know about it, so I will skip that. Next, as you can see from the name, this is basically a casting function. Essentially, there are commands that cast to byte, K, and plot formats. There is also an explanation related to structures, and this part is similar. These are concepts that almost any C or C++ engineer would know. Specifically, the loop, setup, and functions that I explained in a previous lecture are unique to Arduino, and these are included here. This time, we briefly reviewed the basic function list of Arduino. Starting from the next session, we will dive into digital input and output in detail. I will see you next time.